that's the place, location, we need to do the first further explanation. Yeah. Here, I just jump to the slide I need to use to do the explanation. Yeah. So our B.4, yeah. The first one, I need to use this slide to explain. Yeah. All right, so let me get to the right place first. Now we need to do the calculation. Yeah. Based on what I saw in the previous 2 semesters, in this situation, most students, they like to use the variable substitution way. Yeah. So here the first time when I explain the computation like this, let me just use the way you feel more comfortable. Yeah. Because my personal preference, I like to use the differential way. Yeah. But for most students, so they do not feel comfortable about this concept, differential concept. Yeah. So here I like to delay the differential way later, so when we get a better understanding. Yeah. All right. For the variable substitution, yeah, so we use one variable to represent the denominator. So let u equals 50 minus 0.01 y. Okay. Then, after that, we take differential both sides, d operator. Yeah. So du equals d on constant is 0. Then constant multiple, we can take it out. Negative 0.01 dy. Yeah, so we get this relationship. Okay? Yeah, but when we go back, we need to use dy representation. dy equals 1 over negative 0.01, so that is 100, right? Yeah. 100 du. Okay? Yeah. Yeah. So that's when we go back, yeah, we can use this expression. Now, integral dy, that is negative 100, right? Yeah. So we can put a negative 100 in front. Du over u equals dt. Yeah? Yeah. So now it's pretty easy to do the calculation in this form. Yeah. So our next step, yeah, we can get negative 100 natural log absolute value of u, right? Yeah, don't forget this absolute value equals, what's that? T, right? Plus constant C. Yeah. Like this one. Yeah. All right. Yeah. Then we can go back to the y representation, because we can get back to y expression. Yeah, replace u by the y expression. Yeah, and keep the absolute value. Yeah. So the negative 100 we can divide it by to the other side, because c is any constant. So we just keep the same c. Yeah. Yeah, any constant. All right. Now we get this expression. Yeah. Then to solve one little thing I like to have some discussion on, that is this absolute value. Because when we have absolute value, we have two cases, right? Yeah. Positive case, negative case. Yeah. So we may need to consider two possible cases here. Yeah. But here in this situation, yeah. So we have our original question in our original environment. We want to see which of the two cases we should take here. Yeah. Yeah. Probably one of the two cases can be eliminated. So that's what I mean. Yeah. So the positive case could be eliminated, or the negative case could be eliminated. Yeah. So let's go back to the original equation here. Yeah. Yeah. Yeah, because this 5,000 minus y equals 100 times 50 minus 0.01y. Yeah. So now we want to see this 50 minus 0.01y is positive or negative. Can we see it from the given question? Can we see this expression should be positive all the time? Can you see it? Should be positive all the time. Yeah. So let's do here. All right. When we start in 1,000 gallons of water, the amount of salt is 100 pounds. Now let's calculate the initial density of the salt in the mixture. Yeah. Initial density is it 100 over 1,000? That is 0.1 pound per gallon, right? That's the initial density. Okay, all right. Then let's look at the inflow, the density of the salt in this inflow. Yeah. Each gallon contains 5 pounds of salt. That's the density, right? Yeah. So the inflow density is 5 pounds per gallon. See, inflow density always 5 pounds per gallon. The initial is 0.1 pound per gallon. The difference is big, right? Yeah. So much denser inflow brine merge with the, the mixture with much smaller density. Based on that, sorry, the amount of salt Y should be increasing, right? Yeah, because denser mixture brine brings up the density in the tank. Yeah. Yeah. Increasing amount of salt increasing, although you flow out, but the density is reduced, right? Yeah. For the outflow, after you mixed the denser part, less denser part, yeah, right? Yeah. You mix them. Yeah, the outflow density also should be smaller than the inflow density, right? Yeah. So based on that analysis, you can see the Y prime should be positive. Yeah. The amount of salt inside tank should be higher and higher, right? Yeah. So Y prime should be positive. Then this 50 minus 0.01 should always positive. If it's always positive, that means we can remove the absolute value directly. We do not need to keep two possible cases. Here we only have one possible case. All right? Yeah. So the final solution is this one. Yeah. But we need to use the initial value to find e to the c. Yeah. All right. Yeah. So we plug in, so we can get initial value e to the c equals 4,900. Yeah. So the final solution, yeah, here we can get a final solution. 5,000 minus 4,900 times e to the negative 0.01 t. Yeah. From this question, the one point I want to get your attention is this absolute value part. Yeah. Because later in many other questions, you need to do the same thing. Yeah. Yeah, because you will have lot of integrals like this. So you will get absolute value sign. You need to make sure you pick the right case, positive or negative, the right one, based on the given question. Yeah. All right, so that's the first